Module 7, chi-square test of independence. Chi-square test can be used to determine whether the set of observed frequencies on one variable will be the same as the expected frequencies on the same variable. This is known as the test of goodness of fit. The chi-square test examines whether two variables are independent or not. What does it mean to be independent in this sense? It means that the two factors are not related. Typically, in social science research, we are interested in finding factors dependent upon each other. By ruling out the independence of two variables, the chi-square test can be used to assess whether two variables are, in fact, dependent or not. We say that one variable is not correlated with or independent of the other if an increase in one variable is not associated with another. If two variables are correlated, their values tend to move together, either in the same or in the opposite direction. Conditions. Before one conducts a chi-square test, it should be made sure that the following assumptions are met. First, the variable being analyzed must satisfy the conditions of nominal measurement. Second, the sample under study must have come from a random sampling procedure. Third, the expected cell frequencies, at least 80% of them, should have a value of 5 or greater. The criteria are usually adopted for deciding whether or not the number of cases is sufficient to involve the expected frequencies in each cell. Whether any expected frequencies are in the neighborhood of 5 or smaller, it is advisable to modify them like correcting for continuity. Correction for continuity cannot easily be made in the case of a general contingency table. If the number of cells is relatively large and only one or two cells have expected frequencies of 5 or less, then it is generally advisable to go ahead with chi-square test without worrying about corrections. If there are a larger number of small cells, however, the only practical alternative may be to combine categories in such a manner as to eliminate these cells. Of course, categories should only be combined if it is makes sense theoretically. The chi-square test requires a relatively large number because the sampling distribution of the test statistics approximates the sampling distribution given in a chi-square table only when the number is large. How large would the number be to make use of this test? It depends on the number of cells and the marginal totals. Generally, the smaller the number of cells and the more nearly equal is all marginal totals, the smaller the number total can be. The chi-square distribution is assumed to be a continuous one. However, when the number of cases is relatively small, the computed value of chi-square cannot take on very many different values. This is true because observed frequencies must always be integers. In correcting for continuity, we imagine that the observed frequencies can take all possible values and use those values within a distance of half a unit or either side of the integer, obtain which will give the most conservative results. In the case of 2x2 table, a correction for continuity can very quickly be made. It consists of adding or subtracting 5 from the observed frequencies to reduce the magnitude of a chi-square. The chi-square test can generally be used to test the null hypothesis that the sample data have been drawn randomly from a normal population. Example number 1. The following results were obtained from a college student survey on smoking. Do the responses of the two groups differ using the 0.05 level of significance? This is the table. And this is the solution. This is the chi-square result. Decision. Accept the null hypothesis, which says that the responses of the two groups do not differ since the computed chi-square value of 2.246 is less than the critical value of 3.841 at the 0.05 level of significance. Example number 2. A study was conducted to know if hypertension is independent of the drinking habits among 200 male respondents in a certain village. This is the table. And this is the solution. And this is the chi-square result. Decision. Reject the null hypothesis. Therefore, hypertension is dependent on drinking habits since the computed chi-square value of 37.880 is greater than the critical value of 5.991 at the 0.05 level of significance.